Welcome everyone to our lesson in binomial experiments. In this lesson, we're going to talk about fundamental characteristics that define binomial experiments, learn how it's related to what's called the binomial distribution, and we are going to focus on identifying the binomial experiments in this lesson. So let's start with the definition. The binomial experiment is a statistical experiment that has the following characteristics. So in order for it to be considered a binomial experiment, it has to meet these four conditions that are listed right here. The experiment consists of a fixed number of trials. Okay, the next one is each trial has exactly two possible outcomes. It's success or failure. That's why it's called the binomial experiment. There are two outcomes. The probability of success remains the same for each trial. And each of the trials need to be independent of one another. That's the fourth item. So we have a variable x, and it represents the number of successes in the trial. So if you have x is equal to 3, that means there were 3 successes out of, say, 20 trials, or whatever the number of trials is. Now, we have a binomial distribution, and that's the probability distribution that's made up of the binomial experiments. Now, the mean of this distribution is calculated by taking the number of trials, which is n, that's labeled here, times the probability of success, that's your p. And that's specifically on a single trial. Let me emphasize that. And then to find your standard deviation for a binomial distribution, you take your n, which is your number of trials, p, which is your probability of success, and then q, which is listed down here, it's the complement of p, which is the probability of failure. You multiply those three factors together, and then you take the square root, and that will be your standard deviation. So the first 4 examples, we're going to walk through some scenarios, and we're going to identify if all 4 conditions are met. And if they're met, then we can say it's a binomial experiment. So in example 1, it says a basketball player has an 80% free throw success rate. He takes 30 free throws during practice. Check all that apply and determine if this is a binomial experiment. Okay, so the first one that we're going to check, is there a fixed number of trials? It says he takes 30. It doesn't say it's changing. He's taking 30 free throws, so that's a fixed number of trials. So in this case, n would be 30, and it's fixed, so this one is met. The probability of success remains constant. So the probability of success in this case is 80%. It doesn't say that the probability changes with each throw. So the probability of success remains constant. That is met, so we can give that a check mark. Each trial has exactly 2 possible outcomes. So in this scenario, we're looking to see if he makes a free throw or if he misses. Those are the 2 outcomes. So success is that he makes the free throw, and failure is that he misses it. So those are the 2 possible outcomes. So that is met as well. So for the last characteristics, we have to check to see if the trials are independent. And because each shot, which is considered the trial, each trial or each shot, those don't affect the next throw. So the probability of him getting a free throw on the second time is not affected by if he gets it on the first try. So the trials are independent. All of the characteristics are met, so we can say yes, this is a binomial experiment. Let's look at example 2. A school counselor surveys 60 students to see if they are involved in extracurricular activities. However, students are interviewed in friendship groups and their responses may influence one another. Check all that apply. So, are there a fixed number of trials? Yes. Speaking with each student is considered a trial. Every student, when you ask that question, that's one of your trials. And there's a fixed number of them. There's 60. So in this case, there is a fixed number of trials. Xn is equal to 60. The probability of success remains constant. We can assume that there's the same likelihood from person to person. Let's look at the next one. Each trial has exactly 2 possible outcomes. That is very true. Either they're in an extracurricular activity or they are not in an extracurricular activity. So those are the 2 possible outcomes. So yes, that is satisfied. The next one, are the trials independent? That would be a big no. It says in the question that their responses may influence one another. So, for example, if you have John and Judy that are best friends, and Judy says she is going to join an extracurricular activity, that might motivate John and influence his decision to join an extracurricular activity with Judy. So, it says here, their responses may influence each other. So the trials are not independent. One outcome might affect the other. So because the trials are not independent, so we would say this is not a binomial experiment. Let's look at the next example, example 3. A scientist flips a coin until they get 10 heads. Check all that apply. Right away, the very first characteristics that we're checking, the fixed number of trials, this fails. We don't even need to check the other ones. This one fails because it doesn't say they have a fixed number of times that they're going to flip the coin. They don't say we're going to flip it 20 times and see how many times we get ahead. They're saying they're going to keep flipping it until they get ahead. So it's an unknown or a fluid situation where the number of trials is not fixed. So this is not a binomial experiment. Okay, let's look at example 4. It's the last one of these. A teacher randomly selects students to answer multiple choice questions. Each student can answer A, B, C, or D. Check all that apply. This doesn't indicate how many questions there are and how many trials. So this definitely fails. But another thing that's violated here is that each trial has exactly 2 possible outcomes. In this case, there are 4 possible outcomes. The student could choose A, B, C, or D. There's not a success or a failure. It's a choice between 4 options. So this also is violated. So this is not a binomial experiment.